Hey friends, before we jump into today's episode, we want to make sure you know that registration is open for the next free Math is Figureoutable Challenge happening August 26, 27, 28.
Y'all, nearly 40,000 educators have registered for a challenge to date, which is just incredible.
This challenge is all about reaching more students by helping students experience math that connects across grade levels. We'll explore the models that grow with students, like area models, ratio tables, and number lines, so that the mathematical models they learn today keep working and help learning tomorrow.
You'll see how what you do this year feeds into next year's math and beyond, empowering students to build on what they already know instead of starting over every year.
It's 3 evenings where we math together, reason together, and experience mathematics as something that actually makes sense.
We'll meet live each evening at 7 p.m. Central, 8 p.m. Eastern, 6 p.m. Mountain, and 5 p.m. Pacific time.
Y'all, you can register now at mathisfigureoutable.com/challenge.
All right, let's get into this episode.
Woo. Hey, fellow mathers. Kim, think I can do it without reading?
No.
Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
Y'all, we know that algorithms are amazing human achievements, but they're terrible teaching tools because, oh crap, I was good. I didn't have it till there. Because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop. Oh, so close.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Bam. All right, I thought I would try it.
How many times have we said that?
Well, a million. And so one of the reasons I wanted to try it without reading it is because you and I have done a few co-presentations lately where we're in front of people and we obviously don't have notes in front of us. We have little notes, but we don't have whole introductions to the podcast. And I think we did pretty good in person. So I thought, well, shoot, I should be able to do it here. Maybe not.
It's terrible. It's terrible.
When
we got on, you were trying to decide if you were glasses on or glasses off.
Oh, thanks for telling the world.
Well, I think it's funny. It's a legit question because the headphones, man. Sometimes my ears get hot at the end of this situation.
Tell you what, I'm about to take my earrings out because it's.
That's what I was going to ask you. Is do you wear earrings? I know you love the earrings. Do you wear them during?
I'm kind of an earring fan. So I almost always have earrings on during the day. I take them off at night. I slept in them for a couple of years. I don't know what that was all about. I don't do that anymore. But headphones, yeah, it's not the most comfortable. So we'll see. We'll see if I last through this whole episode. You might hear some clinking. If you hear some clinking, it's because I put my. I have a glass desk, so you can kind of hear stuff when it clinks. You don't care. See, here's my glasses. You probably can hear my glasses clink on my glass desk.
Oh my gosh! All right,
I'm glasses off. I am glasses off. How about you, Kim? Are you glasses on or off?
I am. Yeah, I'm contacts most of the time.
Contacts. See, contacts are the wrong distance for my computer.
Well, mine are the weird multifocal.
Same.
I've got old eyes.
No, same, but it's the wrong. Yeah. No one cares about our eyesight. Here we go.
Let's get started.
Kim, the other day, ironically, I was in that's not the right intro for that. Let me just think. The other day, not having to do with math education, you and I both volunteer, do some things around the community, and I volunteer for my church. And I was in a training the other day and they introduced me to this results pyramid. Now, maybe I'm the last person on the earth who has seen it. Or maybe everyone else is familiar with this results pyramid, but I was really interested in it because, man, it fits really nicely with how we think at Math is Figureoutable, how we think about teaching and about professional learning. Mm-hmm. Okay, so I'm going to describe the pyramid. I've told you about it a little bit. You were like, yeah, it seems to fit. So we thought we'd share it with everybody today. I'm going to make my desk go up. I don't know if you can hear that.
100% can hear that.
So nothing like a good standing desk. The pyramid, so you picture, it really looks like a triangle. I guess it's a pyramid, but whatever. On the bottom is the word experiences. And then move up, so you have a little less space, right? Because it's like a triangle. It's the same size height, but because it's a triangle now you have less.
It's like a candy corn.
Up, or if it really
we're
is
all the different colors.
So experiences on the bottom, then beliefs, then actions, then results. Now, let me go down from the top. Results. Hey, who doesn't want results? Do we all want results? We all want results. Like we're working out, we want results. We're learning to cook, we want results. We're teaching, we want results. We are results oriented people. We're looking for good results. Does it make sense then that actions produce those results? Okay, sure. So it's results, then actions. Actions produce those results. And then underneath that, beliefs inform or they influence, they there's a better word I'm looking for. The beliefs that you have create the actions. It's not quite the word I want. They influence, they drive the actions. Inform. I think beliefs inform your actions, and your actions then produce these results.
Yeah.
And so in that candy corn, thanks, Kim, that's nice. In that candy corn, we've got these results on the top. Actions are creating those results. Beliefs inform those actions. They influence them. You do the actions based on your beliefs. If you don't believe in something, often you don't do that action, which then means you don't get that result. So if you have these beliefs, you do these actions, and these actions produce these results. So remember the bottom one, if you can see my hands, I'm like up and down and up and down. The bottom one is experiences. So when we have experiences in our lives, then it creates these beliefs, and these beliefs influence our actions, and our actions produce these results.
Yeah.
That fits for me. What also fits for me, and this actually came out in the church training, was, hey, volunteers, you might be tempted to say to people, we want these results. So because we want these results, do these actions. And then you sort of walk away and you kind of expect or hope that people will do the actions you suggested so that we'll get the results that we're looking for. Kim, how often in education do we see where professional learning will say, hey, teachers, we want these results. We want better test scores. We want happier students. We want students who attend school. We want, let's be clear, better test scores. So do these actions. When what we haven't done is give teachers experiences so that they actually believe that those actions will then create those results. And so they might do some of the actions for a little while. They might even get some results. Test scores might go up. We might see kids doing certain things, but it's not going to last because the beliefs didn't change. And if the beliefs don't change, people aren't going to continue to do actions they don't believe in or that they aren't founded on their beliefs. Could this be the same with students? Maybe, but we, as we, you and I were talking about this and thinking about teaching and thinking about professional learning. So often we see, hey, we want these results better. I want kids to get the answers right. If I want kids to get the answers right, I'm going to tell them to do these actions. Hey guys, just mimic these steps of the algorithm. Bam, you're going to get correct answers. Oh, you don't have that right? Well, here, let's memorize better. Let's mimic. Let's learn some action, some rhymes and mnemonics, and we might even rap to it, or some stories that have nothing to do with math, but it's going to help you remember the actions, do these actions. But we have students who don't believe that math is figure outable. They don't believe that they have the ability to do it. They don't maybe believe that it's worth their time and effort. How many boys do you have in your class? I mean, there's probably some girls too, but I often would have this sort of louder, outspoken guy that was like, why are we doing this? What is this? Let's go play some football, whatever. And in a way, if the actions we're asking them to do are based on doing rote things to get answers that really aren't related to their life and doesn't really interact doesn't affect them, then they might just refuse because their beliefs are, we can learn things in school that relate to me. We can do things that matter, that are, golly, help me, Kim. We can believe that math is figure outable. I don't know if the kids know that right off the bat, but if we don't impact their beliefs, then the actions aren't going to, keep going.
Well, I'm sitting here thinking about how much of the time we talk about the results that we want. It's so prevalent in so many conversations. We talk about the results, and what you're describing here, when we focus on the experiences that impact the beliefs that inform actions, then we get the results. It feels like a more organic, more
Experiential.
yeah, I mean, the results will come, but they come in such a way that we've changed the person, we've changed the subject, we've changed like
The
the way
nature of the
people
subject, I think, is what
feel.
you mean, right? The
Yeah,
nature
yeah,
of, yeah, math
yeah,
became
yeah. Not
figure
math
outable.
changes,
Yeah, yeah.
but I
Or
feel like we focus so much on the results that we're trying to get that we just keep banging our head against a wall to say, do this thing, do this thing, do this thing. But it's always somebody telling somebody else what to do.
those actions instead of, and this is what we promote here at Math is Figure Outable, what are the experiences that we can provide? Hey, how about podcast listeners? You'll notice we often do problem strings during the podcast. We ask each other math problems and talk about what we're thinking about. We believe in giving us and our listeners and people that we interact with and the teachers in our coaching group and the teachers in our workshop experiences so that impacts their beliefs about the nature of mathematics. That's what I
Yeah.
think what you just meant, the subject.
Yeah.
Yeah. And their beliefs in their self-efficacy,
Yeah.
that they can and that it's worthwhile and all of that stuff,
Yeah.
that then leads to them going, well, I can do these mental actions. I can use what I know to reason and think about the math. I can do those actions, and bam, then we get results that aren't just test scores, but we get more kids in STEM. We get kids believing in themselves. We get kids with the doors open to them because math is figure outable and they believe they can do it.
Can I tell you a story about something that happened this weekend that I'm thinking about right now?
I mean, is it completely unrelated? But yeah, go ahead.
Well,
I'm sure it'll be great.
So you know that I love to run, and I
Mm.
do races when I can, and the weirder the race, the better, and whatever. And my kids have known this growing up. And I have a son right now who is running cross country, which I absolutely love. But he has grown up knowing about these races, and he's like, come and cheer me on and make the sign and whatever. And I did a race a couple of times that was, it was a long distance. So it was a couple 100 miles, 6 people on the team, blah, blah, blah. It was a relay. And the nature of the
You're in a
race,
van, right? And you
yeah,
switch
it's
off
like a whole,
legs and all that. Yeah. Uh-huh.
so you do like a 10K-ish, then the next person goes next. And so after, the round one, then you go back out. And the race itself ends up being a whole bunch of 10Ks in like 20 hours for each person. And Cooper knows this, my youngest. He knows that this is a thing that I've done.
Mm-hmm.
But it wasn't until cross country that he had an appreciation for what 10K means. 10,000 kilometers, 6 miles. And
10,000 meters, 10,000 kilometers.
10,000 kilometers. No, 10,000 meters.
10 kilometers.
10 kilometers,
10
10,000 meters.
10,000 meters. There we go.
Yeah.
Okay, good.
6.2 miles. So anyway, we went and did a long run this past weekend.
Oh, in the heat.
It was,
Holy cow.
It's hot. We go really early.
Oof.
Anyway, so he has known about this. It's kind of in the back of head, and he believes that I've done it, whatever. But when we were done and we were sitting there stretching, I said, hey, remember that race that I did? And he was like, yeah. And I said, we just ran 8 miles. So now that you have an appreciation for that, keep in mind that this race that I did that you said, yeah, I'd like to do that one day when I'm older, is 6 or 7 10Ks over like a day and a half. And you should have seen his face, Pam. He was basically like, I'm sorry, what? And in the moment, this is related because he has an experience now of understanding what it means to run 6 to 8 miles.
Yeah.
He knows what that feels like. And before it was just like, yeah, like whatever, anybody can do that. But like in that moment, I was like, I'm so cool to my kid right now because he gets it. He has an experience of these distances and he totally understands now. And he has this belief about what can be possible, but he didn't understand it until he experienced it himself. And so now when I say
not on that level for sure,
no,
right?
and so now when I talk about like training or what you have to do and like the actions you have to take to be able to get that kind of result, it's like it's more ingrained in him. Like he finally understands. Yeah.
Yeah. Yeah.
Yeah.
Sorry to interrupt. Yeah.
No, it's okay. It was one of those moments where I was like, this is a perfect, as you're talking about this pyramid, he now has an experience that helps him understand what it would take and the
The
actions
actions
he
it
would
would
have to
take.
take. Yeah.
Yeah. Yeah. Yeah.
Yeah.
To get those results.
Hmm.
Nice. So interesting. I'll tell a completely related story. So, I have three daughters-in-law, so nobody will know which one this is, but I have a daughter-in-law who's recently been diagnosed as celiac.
Mm.
And Kim, like, this is not just a preference. This is like she gets really sick if she eats gluten. And so I have had to learn to cook differently.
Sure.
And, I had a friend who was celiac and she kind of told me about it. And I was kind of like, wow, that sounds really hard. La, 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 la. But man, like having to do it,
Yeah.
it's just been the experience of you have to rinse everything because if you'd ever put a measuring cup in the flour, you can't now use it even though it looks clean. You got to rinse it out to make sure that there isn't any flour left on it before you put it in the and you have
Hmm.
to have a special container of sugar because if you ever put a measuring cup in flour and then in sugar, then you've got flour in that sugar, so you can't use that
Mm.
sugar even though it's sugar. That's obviously, and
Yeah.
all the things, and then so I've gotten fairly good at that. And the other day we were eating, and God, what did I even do? I put my knife. No, I put my fork in the fruit bowl, which is disgusting. I shouldn't have done that. But I was just, like, and my son goes, "Well, you've contaminated that," and I was like, "Okay, but I just touched that grape, like that one
Yeah.
grape. I didn't." He's like, "Don't put your fork that's been in other or whatever." And then on a different level, so we have family dinner together on Sundays, and they're most often there, and love family Sunday dinner. She came back after Sunday dinner and said that she'd gotten gluten, and I was very polite about it, but she's like, can we think about like what happens so it doesn't
Wow.
happen again? And like even more strong experience that it matters, because
Yeah.
it was kind of like in front of my face. I had this experience of like, oh, I just really sort of poisoned this woman I love,
Yeah.
yeah. So experience really does impact my belief about how important this is, which then impacts everything I do in my kitchen, which impacts the results that I want, which is a healthy, happy
Yeah.
daughter-in-law. Yeah.
I mean, and until you have that experience, like you can think about it. You can like
You can try
go,
your
oh, that's
best.
hard. Yeah, like you said
Yeah.
with your friend, like, oh, that's really hard, but you don't have to deal with that until
It's just,
you
yeah,
really do. Yeah.
it just doesn't really impact you the same way until
Yeah.
you've had that experience. Yeah.
Huh.
Yeah.
Okay, so
Yeah.
let's talk about leaders and teachers.
Yeah. Let's get back to math education. Good, good, good.
So sometimes we see leaders who want to give teachers experiences, right? They want to do math with them, and that's great. Maybe often it comes from they've had an experience themselves and they get a shift, and then
Mm,
like, oh man, I want to provide this for my teachers. I've seen something different. I believe something different. I want that for my teachers. But often they don't take the time to examine the beliefs as well. So like they give their teachers this great math experience, but then that's it. It just like you had the experience and then that's it. And maybe they don't take the time to say, okay, when we've had this experience, what are you realizing now? What are you thinking?
mm,
How will this look in your classroom? Maybe they don't help people realize what the beliefs they have could be shifting and then what actions that they can take that their new beliefs motivate them to do. So, an
very
experience
nice.
is great, but then helping your teachers then examine beliefs and what actions can come from that.
Almost juxtapose their beliefs about the nature of math and the nature of teaching math. Like
Yeah.
what we just did, how does that line up with the way you were taught math? And how does that line up with the way you want to teach math and why?
Yeah.
And kind of helping ferret out, sort of make visible or at least make in the ether, get it out in the ether and help
Yeah.
get people gain clarity around their beliefs so that they can then gain clarity about the actions they want to take so that then they can get the results.
Yeah.
Is that kind of what you're
Yeah,
saying?
absolutely.
Yeah. So that makes me think about manipulatives. Like you and I like manipulatives. We like concrete examples, but we're
Uh-huh.
also very picky about when and how to use manipulatives for reasons. And sometimes we see leaders toss out manipulatives. So we're thinking of a professional learning and they say, okay, solve this problem. And here's some manipulatives. And they say, struggle to solve this problem because we need to get you to feel this is experience, right? We want you to feel productive struggle. But then sometimes teachers look at if the problem is such that it's too easy or too trivial or too forced to have to use the manipulative, if teachers can just sort of see the answer or do the algorithm, an algorithm real quick to get an answer, then they might be like, why are you forcing me to play with these toys? Like, why are you forcing me to struggle in this kind of unnatural way? Yes, it is weird for me to try to shove my thinking into this sort of odd thing. I guess we're suggesting that the task matters. And in that case, if you sort of throw something out and kind of force people to use a manipulative when they kind of don't have to, when sometimes the answer is just there, or they can too easily solve it with an algorithm, then their beliefs about the nature of math and teaching math might actually get solidified, that this is too hard with manipulatives. So why bother with manipulatives? Just tell the kids how to do it. They'll get answers.
Yeah.
And it kind of backfires. So you actually don't shift beliefs in that
Yeah.
way. Or the teachers might now believe that they should force kids to count one by one with these manipulatives instead of helping them develop more sophisticated relationships like additive reasoning or multiplicative reasoning.
Yeah.
So it's one of the reasons why we struggle to try to help give teachers and leaders the vision about the use of manipulatives.
So here's another example is, we love problem strings, obviously, and leaders will very smartly give people experiences with problem strings, but it might be like, a leader is doing a problem string with their kindergarten teachers, but they're doing a problem string that's really too simple for the teachers, and then nothing shifts. Like they didn't have to grapple at all. And maybe the emphasis was maybe only on the answer, and the teachers just get the answers, but there's no shift that really actually happens for the teachers. And so I think it's important that we would recognize that it's not just any experience. Like you're mentioning manipulatives, don't just give them any experience. It's the right experience that is what's going to cause the change in belief. And
at least has the potential to influence their beliefs. Yeah. What about student experiences, Kim?
Well, here's what I have been thinking about ever since we started talking is that we absolutely love hint cards or clue cards for multiplication facts. And I don't know that we're going to describe it all right now, but hint cards or clue cards are ways that we think that are personalized flashcards that help kids through experience work on owning their multiplication facts or addition facts if you use them for that. But what's so great about these is in order to create the clue card or the hint card, you're giving kids experiences where they're focused on relationships. So when they have experiences with the relationships and they start to gain experience and they start to get practice, and
just to be clear, relationships among number, not like peer-to-peer relationships.
Yeah.
Sorry. Relationships among numbers and like chunks of facts to build other facts. Yeah. Sorry. Keep going.
Yeah. So once they start having these experiences, they start to believe that facts are figure outable. So then the actions are, well, I believe that facts are figure outable. So I want to engage in this more because the result I want is to know them.
Yeah.
So they get better in the end because they believe it's figure outable. They put the work in to work on their facts.
So I can think of a higher. Oh, sorry.
Yeah, I was just going to say. So the juxtapose that with I'm just drilling, and I'm not getting experience. I'm not changing my belief that this is doable. I'm cementing the belief that I'm not good at this. So I'm not motivated.
Or I'm a good memorizer, therefore I'm good at math.
Yeah.
And either of those beliefs are not. Like that held me back, right?
Yeah.
So I'm thinking of a higher math example. Sorry for interrupting a second ago.
No, you're good.
I'm thinking of the fact that I really emphasize the power of getting students to walk in front of motion detectors. So high school teachers, even middle grades teachers, the idea of having students in front of motion detectors and seeing the results of their embodied motion really allows them to develop a sense of covariation. I'll say covariation, that means the variables are varying in a connected way. And we can describe that. As time passes, the distance from the motion detector is changing. And those two, time and distance, are connected because as time is varying, the distance is varying in a connected way. And we can describe that mathematically. And so in a huge way, we're giving students an experience that helps them believe that their motion can be represented in this way and that they have the power to then do a representation. So that represented as a graph, and then they can represent that graph with a function rule. And we get these results of more people mathing, doing the mental actions of actually mathing.
Yeah. And once they've had that experience of the motion that they are moving,
Mhm.
tell me more about their beliefs about those kinds of problems. Like, does it feel to them more like that there's
So
not steps to do?
definitely that. So it's an example of, here is a bunch of static information that's sitting on the page.
Mm-hmm.
What's a function? You pick an object from this set and an object from that set, and you pair them together, and you've created a function. Like, that is a definition of a function, but in that, nothing's varying.
Mm-hmm.
And we need both definitions. We need variables to, well, that we can get into that, but we need variables to be sort of the static thing, but we also need them, especially for kids, to understand the general basic ideas underneath calculus, so that then they can be successful. And we can do this as early as like 8th grade, maybe even 7th grade, where the kids really get good at this idea that the variables are varying. Time is changing, and as time is changing, the distance from the sensor is changing. So there's this sense of motion, of fluidness. We have quotes from Leibniz and oh god, who's the other guy that did calculus? High school teachers all around the world are like, Pam, it's Newton and Leibniz, who created calculus at the same time. Both use these words about how variables, they use the words like flowing and fluid. And we talk about this in our 912 book for the Developing Mathematical Reasoning series, where we want to help students believe that variables can vary, that have this sense in the field for covariation. That means that when they are writing the equation of a line, they're not just looking at a formula and plugging stuff in and saying, why did I do that? But they're actually like, I can write a function that represents my motion, the motion I did. I can use actions to do that. And the results are, we get more right answers, but more importantly, we get kids who are thinking covariationally, which builds towards so much success in all the high school math.
Mm-hmm. Yeah.
All right, Kim, that was fun. The results pyramid, everybody. We'll probably talk about that a little bit more coming up. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.
Hey, before you go, this is your reminder that registration is open for the next Math is Figureoutable Challenge, which is happening August 26th, 27th, and 28th.
Y'all, nearly 40,000 educators have already registered for challenges over the years, and we'd love for you to join us at this time to reach more students.
If you've been wondering how today's teaching impacts tomorrow's student, this challenge is for you. You'll discover how connected models help students make sense of mathematics year after year.
When we teach in ways that work when students are young and continue to work as the mathematics becomes more sophisticated, we're setting students up to do even more than we thought possible, because math is figureoutable as it continues.
We'll be live each evening at 7 p.m. Central, 8 p.m. Eastern, 6 p.m. Mountain, and 5 p.m. Pacific time.
Hey, head over to mathisfigureoutable.com/challenge to register.
We cannot wait to math with you.